All right. Hello, everyone. Can you all hear me?
Yeah. Can hear.
All right. All right. Thank you. So yes, my name is Adit, and I'll be your math tutor for today. And as for today's chapter, may I be informed as to what chapter you guys had were taught last week, if you guys were here? If not, then okay, wait. Let me check. Forgive me
I
for
wasn't here last week. Like this
ah.
is my first day, so
Oh, okay. So what do I call you? Shichin was is it or
yeah.
okay.
Shichin will do.
All right. So let me check real quick the schedule, and then we'll be back on track. Uh,
Mm-hmm.
so give me a moment. So this means that hmm. So this means another like 1 minute break lah while I check. I'm sorry.
It's
I think
okay.
it's
It's
already been
okay.
held up for a bit.
Take your time. It's okay.
All right, thank you. But yes, feel free to take a glass of water or any stationaries that you guys need, and I'll be back in a minute. Okay, so since I can't seem to gather the data for the previous class, I think I'll just be talking about measure dispersion of group data, which includes basically your variation, variance, standard deviation, things like that, basically. Okay, so let me just stream it real quick. So, from all of you who are here today, how are you guys with this topic with measures of dispersion of group data, where they talk about interquartile range, variance, etc. What do you guys think of the topic?
I think this is okay, but like if you get one of the numbers wrong, then the whole thing will be like, oh.
Ah, yes. That's true. That's very true.
So
So that's a key point about it. And there are some questions that are quite tricky as well. So give me a moment. I'll share screen.
okay.
And yeah, okay, hold on. Let me just pull up a Jamboard. Okay, so okay, so we're basically going back into if I recall correct, yeah, Sorry. Mm, We're going into the measures of dispersion for group data, which would be, if I flip correctly, which would be describing all about your OGIVs, uh, histograms, etc. So, okay, so the first one we're going to talk about is how to construct a histogram frequency polygon. Okay, I want to ask for both of you who are here today, do you guys want to do this part or do you guys want to skip it? Like the construction and everything, or do you want me to go through it?
Actually, I'm okay with it, but like my school is Chinese school, so we started doing all this in this year. So
Ah,
like what I've learned before is all in Chinese, so I kind of like can't switch the language. So
okay.
I'm not really
All right.
familiar with that.
Okay, but for your SPM, are you going to be taking it in Chinese or English? Or like,
English.
ah,
Yep.
so that's why you're,
So yep.
hmm?
I don't even have the textbook. That's a
I
problem.
see. Okay, Java. I can actually send the link for our textbook right now.
Okay, okay.
Okay, so
Nice.
give me a moment. And for the other person who's here as well, if you have any thoughts you want to share, feel free to put in text if you want. So let me just send it in the chat. Okay, so going through the OGIVE and frequency polygon. Okay, no, not OGIVE, histogram. Histogram is basically like a bar chart. It's almost basically the same thing as what you've learned from before. So let me just take this and put it into my Jamboard real quick. Okay, so if let's say we have this whole thing and we already have this and we want to construct if we want to construct a histogram from this, then we'll have to take this onto a graph paper. And what you want to do is, give me a moment, I'll pull this on here. Uh, what you want to do is construct, make a proper scale first. For example, let's say you have your graph and you have your graph paper. So what you want to do is first you want to find what's a appropriate scale for the whole thing. So if you look here, the frequency is only like 2, 3, 6, 5, 3, 1. And your y-axis will be a frequency. And this is applies for all frequency, polygon, and histogram. So your y-axis will almost always be frequency. On the other hand, your x-axis is the one that changes. In this case, your x-axis would be your height in cm. So essentially what you want to do for, okay, let's say they ask you to do a histogram first. Then you want to take the upper boundary and the lower boundary. Basically what you do is like this. Uh, okay, so if you want to look at the example from the textbook itself, you can see it from here. Basically, yes, you take the boundary and upper boundary, like let's say 145, for example. Uh, Give me a moment. Okay, 145, like let's say 144.5 cm. And then your upper boundary for this group would be 149.5. Basically, when it comes to lower and upper boundary, what you need to know is that it's basically the boundary that's between the limits of the two groups. For example, you see 149, 150. You can see that right in between those two, there's 149.5. This is why we call the upper boundary, because the upper boundary is the boundary that's above this class in a way. So 149.5 would be your upper boundary. Your lower boundary would be minus 0.5 because this one you plus 0.5. On the other hand, this will be minus 0.5. So you'll get 144.5. So in this case, it'll look something like this. And then you'll keep on doing this. As for scale, I think you guys can try figure out on your own. Basically, try to find something that matches the measurements of the graph paper and make sure it's suitable. But for the case of histogram, once you have your scale and everything, you can do it like this, 149.5. Then in this case, the upper boundary of this one and the lower boundary of this one will be the same. So you don't need to write it twice. Then after that, you take the upper boundary of next one like so, and 154.5, 159.5, 164.5, and so on and so forth. You can just keep on repeating this until you just keep on repeating this until you do all of the classes. So from here, 169.5. And lastly, we have 174.5. So from here, you'll be able to talk about how, let's see. From here, you can start to try your histogram. So let's say for a histogram, you put your scale over here as like one box. We assume that one box in your grid paper is 2 cm. So one box can be like one frequency because you can see here, your frequency is 1, 2, 3, 5, 6. So you can say like 1, 2, 3, 4, 5, 6. Basically the same as how you've always been doing graphs. 5, 6. So essentially a histogram is like your bar graph, something similar in a way. So histogram is, what you need to know is that histogram is similar to bar graph. So from here, your 144.5 to 154.5. Oh, wait, no. 144.5 to 149.5, this class. Let's say we call this the red class. The red class over here, you can start making a bar for it. Something like this. And then for SPM, I suggest you don't try shading it in because shading it in means that you'll need to take more time. Just a line will do. A pencil line will be enough. And make sure it's thick enough to seal up. And then you can keep doing this with all the other ones. Okay, any questions so far?
I would like to ask, like, when should I draw the bar one and when should I draw the like freehand one?
The freehand one. Oh, the
Yeah.
freehand one. I think you're referring to. Okay, so when should you draw the freehand one? The freehand one, is it like something like? Does it look something like this? Is that what you're talking about?
Yeah. It's like a curve. You don't need to use any ruler or any stuff.
Oh yeah. Okay, so this one is what you call an O-guide. We'll get into that later on. But okay, so if you want to know the difference between these two, this one is when you want to list out all the frequency of each class. For example, let's say this is the height of students. Then this one is there's 2 people in the first class, 3 people in the second class, and so on and so forth. However, when it comes to OGAI, it's based on cumulative frequency. We'll go into this later on. But basically how it works is that OGAI will start at the, okay, let's say the shortest class is like there's only 2 people. Then the next class has 3 people. But we don't say 3, we say 5. Because OGAI is actually referring to the cumulative frequency, where each class on the graph is actually the first one, tambah all the other ones after it. So from the starting one, let's say, okay, let me just take this real quick and then copy paste it here. Basically, it's something to do with cumulative frequency. So essentially, let's say we take the 2, and then the next one will be 5. So it's plus 3 equals 5. Then after this, you'll add 6. Then it'll become 11. Then over here, it'll become 16, so on and so forth. So this is when you see cumulative frequency. And they ask you to draw an OGAI. Does that make sense? Or not really?
Yeah. I get it.
All
Thanks.
right. No problem. No problem. Okay, let's see. Then we'll go back to this one. Okay, so this one is 2. Like, let's say we go, this one is 2, and then 3, 6. It's not really the best drawing. And then next one is 5, for example. And I think this one you all should be able to do. So 6, 5, then 3 again, and then 1. Now the next part is the next question. They often will ask you something like how to find, how to draw a frequency polygon. Sometimes they ask you to draw frequency polygon and histogram separately, but sometimes they ask you to combine the both. So frequency polygon, it looks something like this. Yeah, it looks something more like this. So basically what you need to do is you take the midpoint. Frequency polygon, make sure you do not draw the points at the upper and lower boundary, but always at the midpoint. So if you look here, like let's say this is a graph paper, then you can just mark the middle of all of the bar graphs. You draw X's on it, basically. And also make an extra one over here. So you draw X's in the middle over here. And this will be your midpoint. Make sure it's right at the middle in your graph. Right now it's not very clear because this is a freehand drawing. But in your graph, it will usually be like something like, let's say, okay. In your graph, it'll be something like this. And then if your bar graph is like, if your bar is something like this, the yellow one, then your midpoint will be right at the middle. Make sure you always mark it right at the middle, not like here or here. So always at the middle. So once you have the middle, and also don't forget put at least some space over here and over here, because here there's gonna be, you'll need extra space for the frequency polygon. So over here, there'll be one more space, and over here, there'll be another one. And of course, the distance should be same. So once you have this, you start to draw your frequency polygon using a ruler. Let me just get a ruler real quick. Okay, a ruler. And you make sure you draw a frequency polygon like so. And this is basically how you do frequency polygon. Okay, but I think I'll do frequency polygon separately as well, because over here, it's one way to do it, but there's also another way to do it. But any questions so far?
I understand it. Yeah, I understand it.
All right. Thanks, Shichin. So we go to the next part. Right. So, okay. So we go to the next part. I clear my annotation real quick. Okay, so we go to ogive. Ogive is the more questionable. Well, not really questionable, but a bit more, quite different from the usual bar graph. So this one, on the other hand, will be based on, instead of just frequency, it will be based on cumulative frequency. So let me just go back to the textbook like just now. Let me just delete some things. So if we go back to the textbook, you'll be able to see that your ogive is like your curvy one. Oh, I mean, we also might be able to go frequency polygon a bit more. Actually, yeah, let me just describe how to get frequency polygon firsthand. Like if you want to do it directly. So your frequency polygon will look something like this. Will look something like what you saw just now. But let's say they don't ask you to do a histogram and just frequency polygon. Then in this case, you need to find one thing first, which is the midpoint. Your midpoint, don't forget your formula for midpoint. Your midpoint formula will be is your upper boundary. Midpoint is your upper boundary plus lower boundary divided by 2. Or also your both will actually work in this case. And in most cases, both will also work. So your midpoint is UB plus LB divided by 2. So in this case, let's say you want to find the midpoint of this group, but they already show it up. You want to find the midpoint of this group. You do 144.5 plus 149.5 divide the whole thing by 2. And then you'll get 147, which is directly in the middle of those two. Which is why over here, in the first part, you draw the x at the middle, because the midpoint is, of course, like it says, is the middle. So a frequency polygon, to draw the graph, you have to start like this. Okay, so to draw the graph, let's say, okay, for frequency polygon, here's one more special thing of frequency polygon you must remember. This is very important. Your thing you must remember is add one empty class above and below. So what do I mean by this? Okay, jump in. So let's say we take this one. You have to add one more class at the top. So I can't really add a class. You can. Okay, jump in. But let's just say I add another class up here. And this one is like like let's say there's another class over here. Then you have to do it something like this. Like let's say you can see the pattern is like 5. So in this case, it'll be 140 to 144. This is your before class. And you want to find the midpoint. The midpoint is the most important class part of this middle empty class. So your midpoint over here, okay, you take your lower boundary, 139.5, and your upper boundary, which is 144.5. Then you do the calculation usual. Or if you want to make it faster, you can actually just look at the difference. So let's say you take this midpoint. You see the difference between two midpoints, 152 minus 147. What is the difference between these two? Does anyone know the answer? Like how much is it between, if you minus
So
152, 147, yeah?
5. So do you need to divide by 2 or what?
Oh, divide by 2, right? Divide by 2, you have to, if you plus upper and lower boundary, and then you divide it by 2.
Oh.
Don't worry, don't worry. Of course, this part can be, yeah, it's a bit, it can be a bit confusing sometimes.
Because I'm like I used to take this in Chinese, so like it's a
Yeah,
bit
lower, it's like
confusing.
a lot of new things, right? Lower
Yeah.
boundary, upper boundary, midpoint, etc., etc. But yeah, the midpoint is the middle. Think it's like, never mind. But yes, midpoint is like the middle part of the two. So upper boundary, lower boundary, you plus these two together and then divide by 2. Or if you want to make it faster, you can find the difference between the midpoint you already have. Let's say, for example, you have this midpoint and this midpoint. Then you can just find that the difference between these two are always 5. It's always adding by 5. So in that case, you can go backwards and you can say the midpoint of the first empty class is 14142, for example. And you can see if you cross-check this with the formula for over here, 139.5, 144.5, then you plus it together and divide it by 2. You'll also get 142. Okay, so let me just show that properly. Because 139 and then 144. And then you'll get is equal to 142. Okay, any question about this part? About like finding midpoint?
No, I get it.
All right. Okay, good. So we go to the next part. So the next part is you add another empty class below. So this part, basically you can see that every class has a size of 5, of basically 5. From 160 to 164, 165, 169, 170, 174. So what would the next one be?
175 to
Mm-hmm.
180.
Close. Very close. Actually, extremely close. Don't worry, don't worry.
Wait, 179.
Yeah, 179. Don't worry, don't worry. So yes, 179. So from here, you can take this, and these are your two extra classes, and both of them have a frequency of 0. So I'll explain why we need this empty classes in a bit. And then your midpoint for this one uh, is so this one, okay, you can just cheat a bit. Your midpoint is just plus 5, and then this one you got 177. Or you can just take lower boundary, upper boundary, and divide by 2. Either one. So your midpoint will be 177. Now, the important part of this I'll show later, but yes, you'll have to make an extra class, upper and lower. The only thing you really need to find for this upper and lower class is your midpoint. This is the most important part. The midpoint of these two classes are the part that you need to find. And these classes are empty. So your next part is actually drawing the whole thing. So for this part, you need to start with your empty class first. So your empty class, for example, would be something like, let's say, in this case, you start with the midpoint of your empty class. So you take your 142. Then after that, you take the midpoint of the normal classes, 147, 152, 157, 162, and then 172. Then from here, you can, and then this will be your height in cm. For frequency polygon, height in cm. For frequency polygon, make sure you use midpoint. Midpoint is the one that you have to use. Use midpoint for the markers. Whereas for the one just now, aka your histogram, you have to use upper and lower boundary. Wait. Okay. Use upper and lower. That's a different thing too. This one you have to use upper and lower, whereas this one you use midpoint. So now, let me go back to the textbook. That's not the textbook.
So like
Mhm.
if they want me to draw the polygon with
Yeah.
the histogram, like should
Mhm.
I straight away just construct one table like with midpoint together, or like I need
Oh, good
to
question.
write two?
For table, right? It really depends on what they ask of you. Okay, let me just check the question in the textbook. But usually when they ask you a frequency polygon, I mean histogram and frequency polygon, you just need to do the upper and lower boundary because your midpoint is always the middle part of the upper and lower boundary. For example, in this case, you can find that they put the midpoint straight in the middle and you don't need to calculate it at all. So you just need to do lower and upper boundary for this case. Let me just check if, yeah, they don't require you to write midpoint. So unless the table needs you to write midpoint, you don't need to put midpoint because frequency polygon, you just need to use upper and lower boundary. Does that answer your question?
Okay,
Yeah, no
thanks.
problem. Okay, so yeah, midpoint, this one you don't need. Midpoint, not needed unless required by question. So if they ask you like to put, if they show you a table and they have midpoint already, then you have to find midpoint. But usually you just need to use lower and upper boundary because that's all you need in the thing itself. Yeah, that's all you need for the histogram itself. Okay, job. So going back to this one, the frequency polygon, you use the midpoint as usual. So job. Of course, we have your y-axis is always frequency. Job. Your y-axis would be frequency. So your frequency would be like 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6. So if we look here, uh, if we look here, you can start seeing the thing. So, okay, so the first one, where the midpoint 142, this is an empty class. So you put it, and the empty class is 0 frequency, which is at the top part here. So you just put the X over here at the bottom for, for the first one. Then the second one, you of course start doing based on the frequency. This one you can see 147 has a frequency of 2. So you do it that the same way. And then you keep doing this with the rest. So 152, I have no space. 157 is 6. I'll just draw over the table for now. 157 is 6. And then 531. Wait. All right, there's one more. Sorry. Don't forget to include both the empty class of the upper and the lower. Okay, 162 is 5. The frequency is 5, so you put it here. And then even going even lower, 167. Wait, did I ever put 167? No, I did not. Okay, forgive me. Give me a moment. Okay, any questions so far regarding this whole thing?
Yeah, I get like it's okay, you don't need to draw the whole thing. The
All
the
right, all right.
one I'm not really good at is like behind the one. The
This one.
what's that?
Wait, where's that?
The variance and the mean and the
Oh, that
standard
one.
deviation. Yeah, that.
Okay, then I'll go check that one. Okay, we'll go skip this for now, since this one you're okay with, right?
Yeah, this one is just plotting the whole thing.
Yeah, that's
I'm
true.
fine with this.
All right, then we'll go to the next part. Oh, guys, are you okay with or not?
Yeah, I'm okay with like these plottings, but
Ah, okay.
the box plot thingy
Oh, the
and
box plot
the
thingy.
yeah.
Actually, a funny story, right? Okay, so since forgive me for talking about myself for a bit, but for SPM 2020, kan, we actually didn't learn anything about box plot. This is actually something completely new in your curriculum. Like,
Oh.
yeah. So I'll try to read and
Yeah,
understand
it's okay.
it.
Take your time. Take your
All
time.
right. Okay, you have learned that box plot is a method to display a group of. Okay, wait. So box plot. Box plot is basically where. Oh, okay, Jap. So your box plot is basically showing where your quartiles are, and your box is where your interquartile range is. Okay, remember OGAT, they talk about something called interquartile range, right? Oh
Yeah.
wait, yeah, yeah,
The
yeah.
0.5, 0.25 thing.
Mm-hmm. Yeah, basically that one, where the first quarter is the lowest quartile, and then the fourth quartile is the highest quartile. Basically, the first quarter is the first 25% of the people. Let's say these people are 25%. And the top quartile is the top 25%. So let's say the highest scoring students, the top 25% in Malaysia, for example, would be placed in the fourth quartile. In the highest quartile. Wait. Uh Actually no, that's incorrect. Hold on. Give me a moment while I think this over. Okay. Actually no. Forgive me. Fourth quartile means that it's actually Okay, maybe I shouldn't use examples to make it more confusing. But a interquartile range refers to, let's say, for example, we have a group of students. We have the two shortest, two really short ones, two a bit taller, and then two that are, actually no, their legs need to be the same. Okay, so two that are a bit taller, and then two that are even taller, and it's actually kind of scary, but yes. And uh, more some that are even taller. So if we go into this, let's say we were to represent this in the ogai, and ogai would make it so that in such a way that the first two will be represented by your first quartile. Then after that, your third quartile will be the number of people of the lowest. Your your Q3 will be the total of 3/4 of the whole thing. So basically, Q2, on the other hand, would be something like your first half. Q3 will be 3/4, and then Q4 will be the entire thing. Something like that. So we put this to Ogai, you know. And I'm gonna talk about how this relates to box plot in a bit. Uh, so we go into, let's say we go into this part, a box plot for a set of group data. So let's start with by taking, let's say, this one. Okay, job, eh? I'm gonna get take a screenshot of this, and then we should be ready to go. Okay, jump, eh? Okay, the frequency table below show that electricity bills are apartment units for a certain month. Construct an OGAI. Okay, the OGAI is actually generally one of the important parts of it. But let me just copy this and you put this here. Okay, we start by making an OGAI, for example. So in this case, let's say we just straight away do a graph. Let's not involve things like upper and lower boundary for now. Midpoint you have to find. Okay, midpoint of this job, eh? Of course they don't have the answer for this question, but I'll go back and reference the previous questions. Okay, jump in. So we go over here again. So in the case of OGAI, make sure that your marker is always the upper boundary. Don't use lower boundary, don't use midpoint, always use upper boundary. So let's talk about that real quick. So let's say we take an OGAI and we want to take the upper boundary. So in this case, your upper boundary of this, I think this one I don't need to cover how to find upper boundary because this is something you can do. Actually, do you need any help with upper boundary or no?
No, you can just skip that part.
All right, yeah.
I already.
All right, that's good. So then then I'll just use the upper boundary of all of these. So we go talk about the electricity bill in ringgit, and we refer to the number of apartment units. Your frequency in this case, instead of frequency, they can sometimes tell you things like number of students, number of cars, but they're all in the end represent the same thing, the frequency of the thing. So in this case, we want to find the number of apartment units that have a certain electricity bill. So yeah. So basically this is talking about electricity bill of different apartment units. That's what the question is all about. So we want to construct an OGAI. And OGAI, we take the upper boundary and you write it down here, 49.5, for example. Then you keep doing this for the other classes. You don't need to make an empty, wait, actually, no, you do. Hold on. Job, let me check if you do. If I'm mistaken, you actually do. Yeah, you need to make an empty class. So for OGAI, don't forget, before this one, you have to make an empty class, which would be, in this case, 10 to 39. Just think of it as like, actually not 10 to 39. Is it? Wait, no, it's 20 to 39, sorry. 20 to 39. So since this 30, 49, 50, 69, 70, 89, this will be 20 to 39. This will be your empty class. And your empty class has the upper boundary of 39.5. This will be your empty class, remember, it has zero frequency. So this one will be marked as zero. So 39.5. And then we go on with this one. This one has 49.5. And then we keep on going with the rest. 69.5. Wait, no, not 40. Wait, am I doing something wrong? Oh no. Oh right, I am. Job, eh? This one is the empty class, sorry, it's meant to be 10 to 29. So from here, you have to write the upper boundary of each class, including the empty class, by the way. And this one will be 29.5, 49.5, 69.5, and you keep going. 89.5 and 109.5, 129.5. I think for cumulative frequency and everything, you're able to do, right, Shuchin? Shichin, sorry.
Yeah. I
All
can
right.
do that.
All right, then I think, yeah, this one we can get that covered. So 109.5, and over here you'll get 1295. I'm sorry I messed up your name, by the way, for a bit over there.
It's okay. It's okay.
All right. Okay, so you have to, of course, for the first quartile, last quartile as usual. This one, the first quartile and the third quartile, that's the most important part. So your first quartile, let's say we zoom in, we take this, and then we go to, okay, this one is, then you have to find the total frequency. So, okay, actually, now I have to actually do this whole thing. So give me a moment. But yeah, we start from 4, and then you plus with 9, you get 13, 24. I won't draw the whole thing unless necessary. 39. Uh, freak, it's a weird number. 52. Okay, here we go. So so of course, to find the first quartile, you need to find the you need to divide it by, okay, let's say you take for the first quartile. Your formula for the point where the first quartile is will be, also remember, calculating first quartile in maths and first quartile in art maths is very different if you're taking art maths. So make sure you're able to differentiate the two. But for math, for modern math, which is this one, your first quartile will be 0.25 times the total, which is 52. And then you'll get, if I'm not mistaken, you'll get 0.25 times 52, you'll get 13. Now, at this point, this means that at point 13, you'll have to draw some dotted lines here, and it will match with the ogai. Okay, now I need to actually draw the ogai. Never mind. So, okay, let me just draw a suitable scale. 10, 15. This is not even suitable. Wait. Uh, let's just write 10, 20, 30.
Actually, it's just actually it's okay. You can just like draw a curve thingy.
All right.
I
Okay,
just
okay,
want,
then I'll draw the whole thing.
I just
Wait,
want to get to
yeah.
the mean and variance one.
Ah, okay. Sorry. I'm making it go too slow. My bad. So then I'll just draw a random curve. Yeah. And then we'll go to, let's say they ask 30, of course. And this will be your first quartile. Then then you have to find the respective electricity bill for the first quartile. And then you do the same thing with the third quartile. Now, how you draw this in a box plot will be something like this. And also you need to find the midpoint. Midpoint is also known as Q2, or the second quartile actually is a better word, is 0.5 times the total. So you'll get, if not mistaken, 52 divided by 2, you'll get 26. So at 26, you'll find the you'll find the second quartile. Yeah, there's a reason why the OGAF is actually quite important. Of course, not always important, but usually in case of box plot, it could actually be, but I'm not sure how the question is. So yes, you have first quartile, second quartile, third quartile. So from here, uh, a box plot. Okay, now the box plot is the important part. And how to draw a box plot is also another thing. Well, not draw, but interpret is a proper way of looking at it. So a box plot, you usually take it something like this. So if you look at it here, if you put an ogive and a box plot on the same graph, then you can see how a box plot is made. So essentially a box plot will be made using, okay, we make a whisker first. The whisker, well, not a whisker, but like the first point. Your whisker is usually corresponding to the upper boundary of 0, the upper boundary of your empty class. This is your first whisker. Then you draw a line, and then until you reach this part, your first quartile. Your first quartile here, you start to draw the first part of the box. Then you go to your third quartile and write the second part of the box. Then you connect these two. And then you keep on drawing another whisker all the way until the ending. Wait, where is the ending? Shit. Hold on. Yes, this is the ending. The ending is the. Wait, no, that's not the ending. Hold on. Yeah, the ending is the upper boundary of the final class, which is over here, which is this part. This is the last class. So this will be your ending, where your final upper boundary will be. And from here, you can continue drawing a box plot over until here. And then after that, you will draw your midpoint. You take your second quartile, and then you connect it and make another line over here. Now, here's the thing. Your second quartile might not always be directly in the middle. Sometimes your midpoint might lie somewhere here. Well, not your midpoint. Your second quartile might lie somewhere here. Or sometimes it can lie over here. It actually depends on the data of the graph. So what exactly can you interpret from a box plot? A box plot can show you whether something is leaning more towards the higher part or the lower part. So let's say, for example, we take a table of XT bills. We can look and see from here, is it more people getting the more expensive bills or the less expensive bills? If it's more people getting expensive bills, then the box plot might be somewhere over here. If it's less expensive, then it might be somewhere over here. Then from there, you can interpret data. You can basically find the data from there. So if you look here, let's say it's basically all about the distribution. Sometimes it might be symmetrical, where the amount of people who are cheap and the amount of people who have a cheap electricity bill and the amount of people who have expensive electricity bill are about equal, which is symmetric distribution. On the other hand, sometimes everyone gets more expensive bills usually, and not a lot of people get cheap bills. Then it'll be what you call less skewed distribution. On the other hand, actually, wait, no. Less skewed distribution, sorry, is if more people are having cheaper bills. Because when a lot of people are here, wait, give me a moment. I need to make sure I got my information correct. Uh, cover 60. Okay. Yeah, this one means that more people are getting the more expensive electricity bills, whereas right skew distribution means that more people are getting the less expensive bills. Basically, if you want to like look at this in the OGAI, sometimes it'll be something like this. So let's say for this case, actually it'll look something more like this. Your OGAIF will look something like since there's more people getting more expensive bills, your OGIF will actually be more towards over here because it increases more towards the end. So your box will be something like over here. Now, on the other hand, if it's more people get cheaper ones, it'll be on the left side. But if the number of cheap and expensive equal, then the box will be in the middle. So basically something like that. But I don't think you'll need to interpret it now. Just you need to find how to get a box plot, this is how. Okay, does that explain? Yeah, does that explain the box plot? Sorry for the late explanation.
Yep, I get it. Like, it's okay. Your
All
teaching is
right.
quite well. Like, I get the point you are trying to say, So
All right. Thank you. Thank
it's
you.
fine to me.
All right. Okay, I'll keep that in mind. So do you want me to go faster or slower with the teaching? Or like, is this okay enough? Like the pace?
It's okay now, but like how can I say it? Like, because
Mm-hmm.
I've learned that when I was from 3, like
Ah,
I'm taking JUEC last time. So
oh.
I get like some wait, hold on. Wait,
Mm-hmm. Don't
I
worry. Take your time.
I get those like those adding up part lah. I get that. So the
Ah,
one
okay.
I was worrying is like the variance thingy, like which should
Ah,
I plus together and which should I divide? Yeah. So
okay. All
yeah.
right. So then we'll go straight to mean and variance lah. All right. Sorry. Okay, job, eh? So then, hmm. So then we'll go on to that part, the one that you actually do need help on. So when it comes to mean, median, wait, no, not median, pula. Mean, standard deviation. I'm gonna hope that I still remember this part because, admittedly, this unit was the one I hated as a student. So let me just try my best. So mean, okay. Let me just take let's just take a screenshot of this and then I'll explain how to get mean as well as standard deviation. Are you taking AdMaths or are you just taking modern math?
Yes, at math sucks.
AdMaths. Yes, AdMath is pain. I agree.
That's just headache.
Yeah, it takes a lot of work for AdMaths. Okay, let's see. Are you Form 4 or Form 5 actually? I'm curious.
I'm from 5, but like this thingy, like this
Mm-hmm.
wait. So this is from the
From
KSSM textbooks,
KSSM.
right?
Yeah.
But the point is, our school doesn't have this textbook. Like we use our own textbook.
Oh wait, so is the
The
curriculum different or is it the same but with different
yeah.
language?
So I've studied Chinese, like I've studied English and maths and Chinese for like 5 years. Then this year
Mm-hmm.
they started to ask me to
Oh.
study this thing in English. Then I was like, what? I mean, I
Oh.
get, but so it's just
So
so
you need to adapt to
confusing.
the new curriculum, to this curriculum,
Yes.
the English curriculum. Is it different or is it like the same, just with different language?
Actually, this is easier than my school science because like
Oh.
SUAC science is like SUAC maths is like different level, but like the
Oh.
some words like some weird words like
Like
interquartile
it's a
range.
quota range.
Yeah.
I see. Okay. Yeah, that one is okay, I can see your predicament now. Uh so then interquartile range. Yeah, I think you know what interquartile range is now, right? I hope.
Yeah.
Okay.
Just like the words sometimes it's kind of confusing. So like, wait, what's this again? I don't know what's this.
What is I see.
Yeah.
Okay. All right, makes sense. So, yeah, okay. Then I'll talk about mean and variance. Okay. So we have this one. We're going to variance. Wait, shit. Hold on. Uh, give me a moment while I check on all of this. Okay. This one is they're asking about hibiscus of hybrid A and B. So this is the diameter of petals. It is basically diameter of petals for hibiscus of hybrid A and B. So okay. Diameter of petals for hibiscus of hybrid A and B. So let's take hybrid A first, because you can't do both at the same time, unless you really want to. But hybrid A, okay, we take hybrid A first. So we divide them to classes as usual. Our classes are, as usual, okay, we take all the classes. And we have 5 classes in total. We don't need to make an empty class for this one because we're not making OGAIF, we're not making frequency polygon. Oh shoot, wait, sorry. I started video by accident. Okay. So hybrid A. So basically this part, uh 13. So your hybrid A, you want to find you start with your listing out all the classes, but you don't really need to do the whole thing lah, unless they ask you to make a whole table. But for the sake of explanation, I'll be doing it all in a table. So we start from here, 14.0, and so on and so forth. I think this part, you can kind of get how to do this part, the table. Now, the next part you need to do is find the midpoint. Now, this is important. The midpoint is going to be important for calculation of mean later on. So they're asking us for this part. Okay. So they're asking us for this part. They want you to find, determine based on the mean and standard deviation, determine which hybrid produces larger and more consistent petals. Justify your answer. Okay, so this is where you need to understand mean and variance better. So larger, they want you to use mean and variance to find which one is larger, find larger and more consistent. Okay. So this one you have to relate with mean and variance. Now, okay, we're going to midpoint. So midpoint, as usual, you can just take the upper boundary, lower boundary, divide by 2, you'll get the midpoint. In this case, if you can just find the middle part over here. I'm just gonna skip through the method. Are you okay if I skip through a method, or do you want me to go through the method?
Yeah, it's fine. It's fine. You can
All
skip
right.
it.
All right. Okay, so then 13.7, 14.2, and we go on with we'll go on with 14.5 to 14.9. Yeah, it turns out I have to write these as well. Okay, 15.0, 15.0 towards to 15.4. And you can find the midpoint of all of these. So your midpoint, you can just calculate on your own, 40.7. Unless if you can you look at it by eye and then immediately tell what the midpoint is, that also works. Like what I've done here. So you don't actually need to show calculation for all this. So if you can just write it straight away, then that's one way you can do it. So this is midpoint. And then you take the frequency of each of them. And remember, we're only taking hybrid A. So make sure you only take the upper part. So hybrid A, we have 4, 8, 9, 10, 9. Now, the next part you have to do is you have to find, okay, this is what we call the frequency. Frequency, we represent F because let's say there's 4 petals within this diameter. 4 of the petals with this diameter. So that means the frequency of petals in this diameter is 4, or F. And the midpoint we'll refer to as X. because the midpoint is like the middle point of these petals. So most of the time, these petals will average out to the midpoint. So we have to times this by, we have to make another column called fx. Now, of course, you don't need to write this all in table form. You can go straight to the method itself. But for this one, I'm gonna show it in table form first. So 13.2 times 4, you'll get 52.8. Actually, yeah, let's just try doing all of this. But if you remember the formula for mean, if you want to straight away find the formula for mean in group data, it's actually midpoint. It's actually not, no, it's actually fx divided by total of f. So if I forgot what the total f is. Wait, yeah, so okay, wait, yeah. Your frequency or the sum of all the frequency, sum f, would be equal to 40. And this is what you need to use for your mean. So basically it's very similar to what you usually use, where you plus them all together and divide them by the groups. But in this case, you're taking the midpoint because we assume that all the petals are close enough to the midpoint, that they are the same as the midpoint. So in this case, we equal this. Of course, you can make another table with all of the fx. Oh, and also this is actually sum of fx. So the total fx lah, basically. So if you want to write it in long form, it'll be like 13.2 plus 13.2 times 4. Of course, I'm not gonna write the whole thing. I'm just 13 point, and now you just keep on going. Like let's say 8 times 13.7. So it's basically frequency times midpoint. And then you keep plusing this all together. And then you just plus dot dot dot. And you divide this by your total of frequency, which is in this case 40. The total frequency, you do it by plusing all of these together. Okay, any questions so far?
Oh, I get this meme.
Ah,
I get
okay,
it.
okay, okay.
I get it. It's something like the what index, right? We just like
Mm-hmm.
times the whole thing and then we just
Yeah, you
divide the
times the whole thing.
total. Yeah.
Yeah, times the whole thing, then divide
Yeah.
the total. So this
Yeah, I
part you
get it.
understand this.
Mm-hmm. Yep.
Okay, then which part are you unclear about?
Actually I got it clear. The box part and this mean part. Like I got it both clear.
Okay, okay. Then which parts?
I think that's all. Yep.
Oh, really? So there's nothing you need help with for the entire thing.
Mm-hmm.
Okay. Huh. Interesting. So then, yeah. Okay. So for I think, okay. So if let's say that as you find larger and more consistent, okay, as the means for a test, as like experiment, uh, which one? If let's say you calculate the mean and variance of both already, so which one would be the large? Which one would be which hybrid would usually have the larger petals? If let's say you have the mean of hybrid A and the mean of hybrid B.
Hybrid A will have the larger ones. I
Why?
guess. Cause like you see the last two boxes, like the 14.5 till 15.4, like they have 19 petals
Yeah,
there.
that's
So
true.
yep.
Yeah, that's actually true. Okay, good. So yeah, that's actually one way you can justify. Basically what they ask for you to do in the end, yeah, you can see like over here, since there's more over here, then the mean will be higher, correct? Because like more of it
Yep.
is a larger
Yep.
value.
Like
Okay,
after
so
my
yeah.
biology, they have like so many tables. And
Yeah, the biology is like table hell.
and physics and chemistry, like
Oh my
oh my
god.
god.
Mm-hmm.
Yeah, so
Yeah. Okay. So then, yeah, the larger one, to find which hybrid is larger, the larger hybrid. If you want to justify this, they ask you to justify with text. Then yeah, say the larger hybrid is the one with the larger mean. But okay, which one will be the one with that's more consistent then? More consistent hybrid. The one with more consistent petals.
The
How would
hybrid
you
B.
okay, but what data would you use to justify?
Uh, wait.
Mm-hmm. You can try anything though.
I guess it's the mean too.
No,
I'm
not the
not
mean.
sure.
Okay. All right. Okay, good. Okay, then okay. It's a good try though. The mean, okay, essentially the mean is the average of all the petals. Actually, you already know this. Like if yeah, usually it's basically like the average of all of the petals. So if most of the petals are bigger, then the average will of course be bigger. Your mean will be bigger. And if more of the petals are smaller, then the mean of course will be smaller because most of the petals are basically just smaller in the end. But when it comes to consistency, it actually refers to something like this. Okay, let's talk about consistency. So let's say we take two sets of petals and we take one set of petals, like let's say we take 5 petals here. These 5 petals are all 5 cm in length. There's no difference. Whereas over here, some of them are 1 cm, 2 cm, 3 cm, 4 cm, and 5 cm. Actually, no, that's not the right one. Jam, eh? Okay, let's say we take some of these are 3. I think you kind of like did something similar to this in the way of, I think something like a plot, like something like 1, 2, 3, but I'm not sure. This one I actually did not learn in school either, but I have seen in textbook. But basically what this looks like is these petals are all 5 cm. And let's say we take these petals, they're 3, 4, 5. No, wait. 3, 4, 5. Not 4, 3, sorry. 6 and then 7. 3, 4, 5, 6, 7. Okay, so let's say I ask you to find the mean. So what would the mean of the first set be of this one? What would the mean length of the petal be?
5.
Yeah, 5. Because if you take all these 5 and then you divide by 5, the average is still 5. 5 cm. The mean length is 5. Okay, but what about the second one?
Hold on, I need to press my calculator.
All right. All right. Go ahead.
Wait, it's also 5. Wait.
Yeah, it's also 5. Basically, the mean is actually like the middle. Kind of like, okay, we take the 7. We have one very big petal. We also have one very small petal. We have one slightly bigger petal and we have one slightly smaller petal and one normal petal. Basically, the excess length of this one will average out the other two. So it's like the bigger ones compensate for the smaller ones, making the mean the same. In the end, like
Oh,
equal.
wait. So the mean is like average, right? So
Yeah, it's the average basically. Yeah,
I
this is
think
what you
I
call the
need
mean.
to use the what standard deviation.
Yes, for consistency, you use variance or standard deviation. Actually, you usually use variance law in most cases, or standard deviation. Wait, hold on.
Yeah, standard
Yeah, standard
deviation.
deviation. Sorry.
You need a wait. But you need a square root.
Yeah, we need a square root.
Well,
Oh, you want to see the formula, right? Is it?
it's okay. I have my book beside me. Like I
Ah,
bought it
okay.
myself. So
All right. Okay. Then yes, standard deviation is like that. Yeah, standard deviation is actually of how varied, a measure of how varied the samples are. For example, in this case, your standard deviation would be, wait, let me calculate it. Shit, this is a lot to calculate. What is the form of a standard deviation? Uh, oh, it's fx squared. Okay. Okay, so let's say we take standard deviation of the first set. So fx squared divided by, let's say we take divided by 40 because, and then you minus this by, God, there's so much stuff to write. 14.35. Wait, what is 14.3? Oh, I'm forgetting so much. Oh, it's the mean. Yes, it's basically like this. This is your form of standard deviation. So you get like something like your mean, which you already know is 25. In this case, your wait, no, this is not 40, sorry. You only have 5 leaves in this case. This is experimental. You have 5 leaves for the first one. So your fx squared, the yeah, you also get 5. You get fx squared would be equal to 5 times 25. And then you get 125 divided by 5 minus 25. You'll get 25 minus 25, which will become 0. The reason why this is 0, the standard deviation is 0, is because there's no deviation at all. All of them are 5 cm. They're all the exact same. So in this case, your standard deviation would be equal to 0 because all of them are the same. There's no variety. Make sense?
Yes, yes, yes. I understand
Alright.
that.
Okay, then we'll go to the next part. Yeah, I think you kind of like understand the whole thing, right? Do you want me to explain further or do you want me to skip this part?
Like I just need the translation thingy for my brain.
Translation. Yes. Okay, makes sense.
Yeah.
Okay, yes. Your consistency, basically, okay, standard deviation will be like this. So your standard deviation starts at 0, which is no variety. So your standard deviation is no variety at 0. But when standard deviation increases, then that means there's more variety. Variety will also increase. So for example, if we look at this one, if we look at the right side, the test subject on the right side of the screen, this one will have a standard deviation that's higher than the first one. Okay, actually, let me calculate this real quick. Let's see if I. Okay, so we have 5 times 3 square plus 4 square. Okay, you know what? I'll just say calculator. 3 square plus 4 square plus 5 square plus 6 square plus 7 square. You get 135. You get 135, and then you times this by your number of petals, which would be 5. And then you divide it by number of petals again. Well, actually, you don't really need to times and then divide, but it's there. But yes, 135 times 5 divided by 5. You minus this by the mean, and the mean is squared. Your mean, as you already know, is 5 cm as well. So okay, we cross out the 5 from each other first. We have 135 minus 25 square, you'll get, wait, no, 5 square, you'll get, chap, did I do something wrong? Oh no. Wait, shit. Chap, 5 square. Oh wait, no, yeah, sorry. You don't actually need to multiply by 5. You just divide by 5 because the number of petals is 5. So this one is, if you want to know how to get 135, just 3 square plus 4 square plus 5 square, and so on and so forth. 3 square, 4 square, 5 square, dot, dot, dot. And then you divide it by the number of petals, which is 5. So 135 divided by 5, and then you minus this with the mean squared. So your mean would be 5 cm as well. So 135 divided by 5 will get something like 135 divided by 5. You'll get 27. And then you minus this by 5 square, you'll get 25. So 27 minus 25. You'll get a standard deviation of 2. Well, actually, not really standard deviation. This is your variance. I forgot to mention. Your standard deviation, you have to square root the whole thing. So your standard deviation would be square root of 2, which is actually still more than 0. Let me just square root 2 real quick into something I can write down. So your standard deviation would be equal to, let's say, 1.414. So essentially, whenever the standard deviation increases, you can see that the more standard deviation, the more the variety. So yeah, does this whole thing make sense?
Okay, I get it.
All right.
Yeah.
Okay, then yeah. So basically, so how would you find a more consistent hybrid? I'm sorry, wait, this is not meant to be variance, this is standard deviation. So how would you find a more consistent hybrid?
Like you compare the both standard deviation, then you will see
Yeah.
like which is higher, then it's more consistent. Wait,
Ooh.
hold on. Wait.
Close, very
the
close, very close.
the lower one is the more consistent one.
Yeah, that's correct. That's
Yeah.
the one with lower standard deviation is more consistent. All right, then I think you've basically got this whole chapter done without. Yeah, I think you've got most of this chapter down. Okay, anything you want to ask in regard to this chapter?
Hold on, I just go through the pages and see like.
All right. If there's any you have in mind, then I can try going through.
Okay.
Mm-hmm.
So about the range, it's like midpoint of highest class minus the lowest class.
Midpoint of highest class minus range.
Yeah.
Range. Range. Yeah, that's correct. Midpoint of highest class and midpoint of lowest class. Wait up. I'm actually not certain. Hold on. Jump in. You're talking about just range, right? Not interquartile range.
No, just range.
Just range. Let me check.
Yeah.
I actually need to check that one. Actually, no, that's not range. That's domain, if I'm mistaken. Unless. Okay. Yeah. Okay. Range is actually, if I recall correctly, your range is actually, let's say, okay, let's go back to our first histogram. You see how that one of them, the highest frequency is 6, right?
Yeah.
And your lowest frequency is 1. So your range would actually be the highest frequency minus the lowest frequency. That's the range. Your domain is the one you're thinking about, I think. Highest frequency minus lowest frequency, unless I might be wrong. Yeah, highest frequency minus lowest frequency. So this is
the
what you
whole
call
graph,
the range.
yeah, the range of the whole graph is like 1 to 6.
Yeah, 1 to 6. Yeah, that's what you call the range.
Oh, okay.
Mm-hmm. Whereas, yeah, I think it's highest, but I don't think you write it at 1 to 6. Wait, let me check. Range. Okay, no. How to find range? Group data. Just to make sure. Okay, never mind. I am dumb. Yeah, okay, sorry. It's not what I was thinking. No. Range is yes, upper class boundary of the highest. Okay, sorry. Okay, I think I mistook what it meant. Range is actually the range of the like let's say we're talking about length of petals. So the range is actually the range of what the petals can be. So let's say from 3 to 7, this will be your range. It'll be 7 minus 3, for example. So your range will be equal to 4. This one minus this one. This is if it's ungrouped data lah. Okay. So this is what you call the range. From the highest, the longest minus the shortest. Make sense? This is if
Okay,
it's
okay,
ungrouped. Okay, but
okay.
if it's grouped, your range is not the midpoint of the highest minus the midpoint of the lowest. It's actually the upper boundary of highest class minus lower boundary of lowest class. This is the how you find the range. Because let's say we do an experiment with the students earlier. The students must be either they have to be within the range of this, they have to be within the range of 144.5 to 174.5. They can only be within this range because that's the range of this whole experiment. That's what you call the range. So your range is your upper boundary of highest class minus the lower boundary of lowest class. That's what you call the range. Make sense?
Yep, I get the thing. Yeah.
All right. All right then. So yeah, any other questions?
I think I'm done with this
All
this
right.
chapter.
Okay, any chapter you want me to brief in like the next part that I can somehow like okay, any question for any other chapter that I can take only 5 minutes to answer?
Let me go through my books.
All right.
Actually, like the KSSM Form 4 books, like I've
Mhm.
covered this thing, these chapters when I was Form 2.
Oh God.
So it's like,
Oh,
huh? Why
Chinese
am I
school
learning?
sounds hard.
Why am I learning sets at Form 4? Wait, what?
My
And
God.
like the number bases and the quadratic functions, I've learned that when I was Form 3. So it's like,
Mm.
huh? Why the KSSM
Oh,
syllabus is so weird?
my
So I
God.
just
So you guys are like super advanced lah, basically.
not super, like kind of ahead.
Kind of ahead. Okay, makes sense. Okay,
Um, so like basically
most
mathematics is just this.
it's just this.
Yeah.
So this part is the only
So
thing you're having trouble with. Okay, anything else you're having trouble with?
let me see.
But
Actually, it's
don't ask me about the consumer ones though, because that one I'm not sure.
actually it's okay for me because like the trigonometric thingies we've learned it when I was learning at
Ah,
maths. So
right.
yeah. And the variation thingy, I think I've learned it when I was Form 3, but I kind of forgot some of it.
I see. Okay.
Yeah. But I think I've seen this when I was studying physics.
I see. Oh, like all
The
the
what
waves.
directly proportional,
Right,
inversely
directly
proportional.
proportional.
Yeah.
It's that one's to do with yeah, you can see that in physics a lot.
Wait, hold on. Is it the
Huh?
same thing?
It's basically the same thing.
Oh,
Yeah, it's actually the same thing. It's the exact same definition.
oh
So
my god.
where in math, you're directly proportional, your math and your physics directly proportional will all mean the same graph. Math and physics. It will all mean like let's say they're talking about directly proportional. Your graph will always look like this, starting from 0 going upwards. Or like this. It really depends on the constant. So yeah, that's what they mean by directly proportional. Sorry, not physical, physics. So it's the same thing.
If it's the same thing, then okay.
Mm-hmm.
Okay. I think I'm okay with that.
All right. Then I
So
think you're able to do like all the variation you're able to do, right? Like all the fission. Like
yep.
if I showed you this, then you'll be able to do right.
Mm-hmm.
All right. Okay,
This
then
is
it's
I
already
think this is just simplified at maths. The easy
simplified advanced.
version. Yeah.
Yeah, basically. My God.
Oh
Uh,
my god. So
hmm. All right.
I think it's
Yeah, it's already time. On another note, I have a question. This is related to HFE's recent project. Uh, do you have Discord as a social media platform that you use?
Yep, I have a Discord account.
Ah, because recently, wait, let me just show you Hands for Education Instagram page. Okay. Actually, where did you hear about this Project Didik program? I want to ask.
I just saw it on Instagram, like just
Ah,
randomly scrolling, and I just saw
I
this.
see. Then you saw this lah.
Yeah.
Okay. Because another thing that we have going on is if you have a Discord account, we're doing a thing called Save SPM 2021, where students can students basically like hang out there and like collaborate with each other and work together in like study groups. And some tutors will be there to like give classes as well. So yeah, if you want, I can send a link like in the chat.
Oh, I think I've joined that. Wait.
Oh, you have. Oh,
Yeah.
what's your username, Jab?
Wait, hold on.
Wait, okay, yeah, wait, let me see.
I think they somehow sent an email to my account because I've changed my.
Oh,
Wait,
okay.
hold on.
Because I'm managing the server, so I think so if I look through, I would be able to see it.
Oh, they need me to verify. Okay.
Ah. Mhm.
Uh,
Then yeah, because I'll be teaching. Yeah, I know this is a bit of a promotion thing. But as part of as the one of the managers for Save SPM 2021, I'll be teaching physics tomorrow as well. If you're physics tomorrow as well. So yeah, and basically like in this server, you can like study with other people and things like that,
oh,
lah, basically. That's what we're
oh,
planning. Yeah.
hold on. I just joined it. Yeah.
Mm-hmm.
Is it the study together thingy? Wait. Uh,
Oh yeah,
yeah.
Jinghan. Wait, sorry. Let me just say something to the facilitator real quick.
So is it like the same time tomorrow or what? Cause
Tomorrow, yeah, it's 9 to 10 p.m. But